So the accuracy and precision of an instrument depends upon its design, material used, and the workmanship that goes into making the instrument. So we know already the definition for accuracy and precision of an instrument in the system. So the choice of the instrument for a particular application depends upon the accuracy desired. Similarly, if only a fair degree of accuracy is desired, it is not economical to use the expensive materials and the skill for the manufacture of the instrument. But an instrument used for an application requiring a high degree of accuracy has to use the expensive material and a high skilled workmanship. So the economical production for any instrument requires the proper choice of material, design, and skill. So these three things are required for economical production of any instrument. In order to assure the purchaser of the quality of the instrument, the manufacturer guarantees a certain accuracy. In most of the instruments, the accuracy is guaranteed to be within a certain percentage of full-scale reading. So the components are generally guaranteed to be within the certain percentage of the rated value. So the instrument in most of the instruments, so the accuracy is guaranteed to be within a certain percentage of the full-scale reading. Generally, the manufacturer has to specify the deviations from the nominal value of the particular quantity. The limits of these deviations from the specified value are defining as the limiting errors or guarantee errors. The limits of this deviation from the specified value are defining as the limiting errors or the guarantee errors. The manufacturer guarantees or promises that the error in the item is selling is no greater than the limit set. The magnitude of a quantity having a nominal value AS. So A suffix S is nothing but nominal value, and the maximum error or the limiting error of plus or minus del A. And it has a magnitude AA between the limits AS minus del A and AS plus del A. These two are the limits AS minus del A and AS plus del A. So the actual value of the quantity can be calculated as AA equal to AS plus or minus del A. So for example, the nominal magnitude of a resistor. So consider a resistor which is 100 ohm and the limiting error is plus or minus 10 ohm. Limiting error is plus or minus 10 ohm. The magnitude of the resistance will be between the limits. That is AA equal to 100 plus or minus 10 ohm. So now the AA becomes greater than or equal to 90 ohm and AA is less than or equal to 110 ohm. That is 100 plus 10 which is equal to 110. So AA is less than or equal to 110 ohm. Similarly, 100 minus 10 equal to 90 ohm. So AA is greater than or equal to 90 ohm. The manufacturer guarantees that the value of resistance of the resistor lies between 90 ohm and 110 ohm. Next, we will see the next term in this error analysis, that is relative limiting error or fractional limiting error. So the relative error or relative fractional error can be defined as the ratio of the error to the specified magnitude of a quantity. So it can be defined as the ratio of the error to the specified nominal magnitude of a quantity. So the expression is a relative limiting error epsilon r equal to del a divided by as, which is equal to epsilon naught divided by as. So epsilon naught equal to del a, which is equal to epsilon r into as. So epsilon r is nothing but a relative limiting error. Next we will see types of errors. So the error can be classified uh, depends upon the arising from the different sources. So no measurement can be made with perfect accuracy, but it is important to find out what accuracy actually is and how different errors have entered into the measurement. So a study of errors is a first step in finding ways to reduce them. So errors may be arise from different sources, which are usually classified into three, that is grass errors, systematic errors, and random errors. Now let us discuss these three errors one by one. First one is grass errors. This grass errors mainly covers human mistakes in reading instruments. While taking the reading in the instrument, generally human made some mistakes. So this mistakes comes under the grass errors. And also recording and calculating measurement results. So by recording the various parameters or by calculating the various parameters, uh, the errors comes in. So these errors are comes under grass errors. So the responsibility of the mistake normally lies with the experimenter. The experimenter may grossly misread the scale. So while taking the reading, or suppose the experimenter uh, misreading that the readings means, then this type of error occurs. So for example, if a person due to an oversight read the temperature as 31.5 degrees C, while the actual reading may be 21.5 degrees C. That is, the actual reading is 21.5 degrees C, but due to oversight, person measures or read the temperature as 31.5 degrees C. So this error is the grass error. And suppose a person transpose the reading while recording. For example, he may read 25.8 degrees C and record 28.5 degrees C instead. So instead of 28.5 degrees C, he read or he measure 25.8 degrees C. So this is the error. It is called as grass error. But as long as the human beings are involved, some grass errors will definitely be committed. Although complete elimination of grass errors is probably impossible, one should try to anticipate and correct them. So the complete elimination of grass errors is impossible, but each and every person try to anticipate and correct them. So some grass errors are easily detected and some grass errors are very difficult to detect. So grass errors may be of any amount, therefore the mathematical analysis is impossible. So far we have discussed what is meant by grass error with some example. Next we will see the next type of error, that is systematic error. Systematic errors are repeated consistently with the repetition of the experiment, which are caused by some effects that are sensitivity shift, zero offset, no non-linearity. So these errors cannot be determined by direct and repetitive observations of the measurement made each time with the same technique. So these errors can be located only by having repeated measurements under different conditions or with different equipment and where possible by an entirely different method. So generally these errors, that is the systematic errors. So systematic errors cannot be determined by direct and repetitive observations of the measurement made each time with the same technique. Next, we will see the types or classification of systematic errors. So systematic errors can be classified as three types. First one is instrumental errors, second one is environmental errors, and the third one is observational errors. First we will see. First we will discuss instrumental errors. So these instrumental errors arise due to inherent shortcomings of the instruments. Second one, misuse of the instruments. Third one is loading effects of instruments. So these errors arise due to inherent shortcomings in instruments, misuse of the instruments, and loading effects of instruments. So instrument errors are inherent in instruments due to construction, calibration, or operation of the instruments. So these errors may cause the instruments to read too low or too high. So some examples of these errors are mechanical friction and wear, backlash, yielding of supports, pen or pointer drag, and hysteresis of elastic members due to aging. These are some examples. And next example is constructional faults resulting from finite width of knife edges, excessive friction at the mating part, lost motion due to necessary clearance in the gear teeth, etc. So these are some examples of the instrument errors. Second, improper selection and poor maintenance of the instrument. So if you select the instrument improper, or if the maintenance is poor, the instrument means, then this error occurs. And the next one is unavoidable physical phenomenon due to friction, capillary attraction, and imperfect rarefaction. So these are the various reasons. Next one is assembly errors. So assembly errors. So these errors arise due to this some reasons. What are the reasons? Means first one is displaced scale. That is incorrect fitting of the scale 0 with respect to the actual 0 position of the movement. Second one is non-uniform division of the scale. Suppose in the scale in the instrument, if there is a non-uniform division presence means, then this assembly errors occurs. Third one is bent or distorted pointer. And next one, the assembly errors due to the assembly errors do not change with time. So this can be easily discovered and rectified. Next, we will see the misuse of instruments. So a good instrument used in an unintelligent way may give a erroneous results. So if any person used the instrument, used the good or perfect instrument in an unintelligent way or in a different way means, then it will give erroneous results. Next, we will see loading effects. So loading effects means in several measurement techniques, the detector or sensor utilizes the energy of the medium, thus altering slightly the parameter to be measured, resulting in errors. Next, we will see the next type of error, that is environmental error. So the environmental errors are due to the conditions external to the measuring device. Example, effects of pressure, temperature, humidity, dust, vibrations, external magnetic or electrostatic fields. Actually, these errors are much more troublesome than the assembly errors. These errors can be completely eliminated or reduced by taking some measures. That is, using the instrument in controlled conditions of pressure, temperature, humidity in which it was originally assembled and calibrated. Second, measure deviations in the local conditions from the calibrated ones, and then apply a suitable corrections to the instrument readings. Third one, automatic compensation for departures from the calibrated conditions by using sophisticated devices. So by using sophisticated devices, automatic compensation for departures from the calibrated conditions can be done. Next, make a complete new calibration under the local conditions. So under the local conditions by making a complete new calibration. Next, in case it is suspected that external magnetic or electrostatic fields can affect the readings of the instruments, magnetic or electrostatic shields may be provided. Next, apply computed corrections. Apply computed corrections. Normally, efforts are made to avoid the use of applications of computed corrections, but these corrections are needed and are necessary. They are incorporated for the computation of the results. So by applying computed corrections. Next error is observational errors. Actually, these observational errors are occurred due to the carelessness of operators. The operator or if a person using the instrument means, then due to the carelessness of the operator or a person means, then this type of errors may occur. Even when an instrument has been properly selected, carefully installed and faithfully calibrated, shortcoming in the instrument occurs due to certain failings of on the part of the observer. So the observational errors may be due to some reasons. So what are the reasons means? First one is parallax. That is parallax error. So since the parallax errors arise on account of pointer and the scale not being in the same plane, we can eliminate this error by having the pointer and the scale in the same plane. So this parallax error can be avoided by having the pointer and the scale in the same plane. Wrong scale reading and wrong recording of data. If a person take the reading and recording means if he records that data in a wrong way or a wrong scale reading means, then this type of error occurs. Next, inaccurate estimates of average reading, lack of ability to interpolate properly between graduations. Inaccurate estimates or inaccurate calculations of average reading. It's a lack of ability to interpolate properly between graduations. Next one, incorrect conversion of units in between consecutive readings and non-simultaneous observation of interdependent quantities. A person doing the conversion Next one is incorrect conversion of units in between consecutive readings and non-simultaneous observation of quantities. Next one is a tendency to read high or low, anticipate a signal and read too soon, personal bias. So if a person read the readings very high or very low, anticipate a signal and take the readings too soon means then this error occurs. So modern electrical instruments have digital display of output, completely eliminates the errors on account of human observational or sensing power as the output is in the form of digits. Next type of error is random errors. Actually, these random errors are accidental, small, and independent. There are very small error and it occurs due to independent. They vary in an unpredictable manner. The magnitude and the direction of these errors cannot be predicted from a knowledge of measurement system. Magnitude and the direction of these random errors cannot be predicted from a knowledge of measurement system. However, these errors are assumed to follow the law of probabilities. So the most common causes of these errors, random errors are: first one, friction in an instrument movement. Second one is backlash in the movement. Third, parallax errors between pointer and scale. Fourth one is finite dimensions of the pointer and scale divisions. Fifth one is hysteresis in elastic members. And sixth one is mechanical vibrations. These are the common causes of random errors. Okay. First one is friction in instrument movement. Second one is backlash in the instrument movement. Next, parallax errors between pointer and scale. Fourth one is finite dimensions of the pointer and scale divisions. Fifth one is hysteresis in elastic members. And sixth one is mechanical vibrations. Next, we'll see what are the various sources of errors. So the various sources of errors are: first one is noise, second one is response time, third design limitations, fourth one is energy exchanged by interaction, fifth one is transmission, fifth one is detection of measuring system, sixth ambient influences on measuring systems, errors of observation and interpretation. So these are the various sources of errors. Now let us discuss these sources of errors one by one. So first one is noise. So noise means it is defined as any signal that does not convey useful information. Any signal does not convey useful information means then it is called as what? Noise. So noise means or noise error can be reduced to a minimum level through filtering, careful selection of the components, shielding and isolation of the entire measuring system. That is how the noise signals or errors occurs due to noise means which can be reduced to a minimum level through filtering, careful selection of components or instrument, shielding and isolation of the entire measuring system. And the second source of error is response time. So response time means it is the time taken by the instrument to show 53.2% change in a reading to a step input. This is the time taken by the instrument to show 63.2% change in a reading to a step input, which is called as response time. So this factor contributes to the uncertainty of the measurement. Third one is design limitations. So in the design of the instrument, certain inevitable factors such as friction and resolving power lead to uncertainty of measurements. Next one, energy exchanged by interaction. Energy exchanged by interaction. Whenever the energy required for operating the measurement system extracted from the measurand, the value of the later is altered to a greater or lesser extent. This alternation is dependent upon the capacity of the system. So due to this energy exchanged by interaction, errors are present. These are also a source of error. Next one is transmission. During the transmission of information from the primary sensing element to the indicator, the signal may be attenuated due to some reasons. So what are the reasons? First one, it may suffer loss through leakage. May suffer loss through leakage. It may be absorbed or otherwise consumed in the communication channel. Third one, it may be distorted by resonance, attenuation or delay phenomenon whose actions are selective on various signal components. So these are the various reasons that the signal may be attenuated. First one is it may suffer loss through leakage. Second one, it may be absorbed or otherwise consumed in the communication channel. Third one, it may be distorted by resonance, attenuation or delay phenomenon whose action are selective on various signal components. Next, deterioration of measuring system. Deterioration of measuring system. The examples of some types of deterioration which occur in a measuring system and result in an as a source of error in measurement are change in resistance of a circuit element through strain relief. Change in resistance of a circuit element through change through strain relief. Next one is alteration of thermocouple characteristic through oxidizing or reducing atmosphere. Alteration of thermocouple characteristics through oxidizing or reducing atmosphere. Next one is ambient influences on measuring system. Ambient influences on measuring system. And last one is errors of observation and interpretation. So these are the various sources of errors occurs in the measuring. Next we will see statistical analysis of test data. So the systematic and the random errors are evaluated and studied by statistical procedures, which make it possible to state from a limited group of data the most probable value of a quantity, the probable uncertainty of a single observation, and the probable limits of the certainty of the best value that can be derived from the data. The experimental data is obtained in the two forms of test. What are the two forms of test? First one is a single sample test. Second one is multi-sample test. So in a single sample test, a single measurement or succession of measurements done under identical conditions, excepting for time, which is known as single sample test. So a single measurement or succession of measurements done under identical conditions. So identical conditions means same conditions excepting for time. It is known as single sample test. Next, multi-sample test means repeated measurements of a given quantity are taken under different systems. different test conditions, the repeated measurements are taken, such as using different instruments, different ways of measurement, and by employing different approaches, called as what multi-sample test. So this type of test does not serialize results by simply making measurements to the same procedure technique under the same observer. Actually, in statistical averages, we are calculating the various parameters like arithmetic mean, geometric mean, median, and the mode. Also, dispersion from mean. Dispersion from mean, average deviation, standard deviation, best value from a sample of readings. Like that, calculating so many parameters. Similarly, we are calculating the normal or Gaussian curve of error.